and the installation.
Yeah, you're live. Sorry to cut you off, Red. You can continue your AutoCAD frame
Fusion 3D, right?
description of a.
Wanted to say that everything about Fusion 360 is awesome, except for installing, signing in, dealing with accounts, and otherwise getting it for free without paying. It's a pain.
Okay.
It's Autodesk, so yeah, I can imagine. So
Like, it's for free if you're into like a hobbyist, but like they don't make it easy.
yeah.
There was another one that is, oh god, it's like very AI centric and API driven. That's like a startup in LA. I'm trying to remember what it's called.
For mechanical CAD?
Yeah.
Okay.
I'll find it.
What is the one we were using for electrical that was AI driven? I forgot. Flux.
Flux, yeah.
We used it a couple of times. Yeah, right now I'm actually going through a couple of the MIT OpenCourseware electrical engineering courses, and I'm looking for the best, simplest, basic circuit simulation tool, not layout and PCB design, but just like, the circuit simulators. What, do you know which one?
You can use Spice.
Spice.
It's the standard one. I've not heard anything other than Spice. So most of the other open source version to build on that. So Analog Devices has one of them. It's called LT Spice.
I've heard of LT Spice for some reason, but not Spice.
So the Spice is basically like the base simulator, and then people build on top of it.
Oh, okay. Kind of like a physics engine for the circuit.
Yeah, it seems something like, but I don't know the internals. But yeah, so this seems to be, and like all the KiCad also has a Spice simulator, I think. So if you just search Spice, it should.
Yeah, the reason I'm getting into it is, I figured, like I was posting in the channel, maybe we should get back to a rotation scheme that we used to do a couple of years ago. But back then we were each doing our own builds and we would give a build update or something. Now that we've kind of converged on at least an idea for where we are going, might be better to do the rotation on functions. So like I posted, my interest, I think, is one level up from mechanical CAD now, which would be power and charging. So batteries, solar panels, inductive charging. That's why I posted the inductive charger link. And that's why I'm doing the power electronics MIT course, which is kind of interesting. Yeah, maybe we can talk about that first. The Adafruit thing I posted. Let me share my screen. That might be worth spending a few minutes sharing. Let's see. Yeah, so you can buy things like this, which I was not aware of. Just a basic inductive charging kit. And the interesting part is, this.
How do you attach it to your battery? That's a question.
No, this would not be battery. This would be plugged into the wall.
No. But I have a robot with a battery, a tumbler.
Mm-hmm.
How do I get the tumbler to be charged by this?
Yes,
I don't mean the mechanical part. I mean the power part.
Yes, that's what I'm getting at. So this would be the base station. I don't know what the other end looks like. But the interesting part here is you can draw as much as 500 milliamps if the coils are 2 or 3 millimeter apart, which means you don't need any kind of like mechanical coupling device. You can have like the rover come and just park over the charging pad, and that should be enough to charge at 500 milliamps, which is about 4 hours for a 2000 milliamp hour battery, which is, I think, the largest we've talked about. The one I have on my rover is 700, so that'll be an hour and a half. So I don't know quite how it works, but there's 2 coils. I imagine one goes on the rover, the other plugs into the wall charger, right?
Yeah, so what is the output? If the output is 5 volts, then you might need a step up
Yeah,
out
it
of
is
boost.
5 volts, but the battery you bought for the ESP cam
Yeah,
took
yeah,
I mean, it's the
that could be
same
charged.
as charging from USB, right?
yeah,
Yeah,
that's what I'm getting at. So if we have this and we couple it with a battery like this one takes a USB charging port, um, and then we can like do some like buck or boost converting or whatever is needed to drive the rest of the power from this battery, right? So
yeah.
that's
So this might not need any conversion because it has the circuitry inside.
yeah. This to
Yeah,
charge it won't need, but
yeah,
on the output side, 5
yeah,
volts and 3.3 volts run those two kinds of electronics. But if the motor needs like 6 volts or
yeah,
something,
yeah.
you need some conversions, right?
Yes, yeah.
Yeah. But the basic idea sound have a rover that hovers over a charging pad, sits there, and then the gamification at the social level would be the rover in the frame would say needs charging, and then if you drive it over to the charging pad and charge it, maybe you earn 1 point, something like that.
Maybe the other way around. If you want to use it when it's getting low on battery, the price goes up.
So
Yes.
Yeah, but you do need some sort of mechanical coupling, not a plug, but when you sit, getting to be at exactly the right location is not easy. So you
So
need
the
some sort
way
of
I would do
mechanical
that
guide.
is we have a FPV camera on the tumbler at least. You would give it a target, and then the driving challenge would be come and put the target in the center of your camera frame. And when you're in the right position, you will be hovering over the charging pad, right? So that's one hacky way to do it. Yeah.
Yeah,
I
so we could have some fiducials near the charging station,
What's
and
a
then basic fiducial is our markers which you uh, use in computer vision for localization. Yeah, it's like black and white specific markers that is easy to identify. So
okay.
you have fiducials on PCBs when for placement. You have fiducials in robotics for like a navigation. So you place like specific markers which is easy to demarcate in computer vision.
So
In related news, the extremely cheap Google Vision model just came out like yesterday, that are much better at spatial reasoning in images. So I was kind of excited to try that out with my other
What is
vision
it
stuff.
called?
But like, it's the Flash 2.0.
Okay.
so
They were
this
showing some demos of like it drawing bounding boxes around objects because it could actually identify where in the image the thing was and draw the
So
bounding
it
box.
will work on Raspberries.
Well, no, it's still cloud based. So we're talking about a cloud environment, truly.
this seems simple enough that you could use like an onboard camera like OAK-D, retrieve, do the segmentation, do some simple arithmetic to figure out like where you are in like space relative to that, right? Like,
You can do
I
that
mean,
with the ESP.
okay,
those
that's
are
what,
certainly solved problems, but not necessarily simple or not necessarily easy to solve.
so I guess that brings up another good module for somebody to take over and own. So power subsystem will require some image processing to do this. So
And
maybe image,
docking, yeah.
And various
Possibly
other things. I mean, this power charging is one application, but everything else, right? Like maybe it needs to, if it gets too hot, maybe it needs to go park in the shade to avoid overheating. So lots of like applications for image-based behaviors, right? So image processing
Yeah.
seems like a cluster somebody should own.
But even if
I
it's on the
personally
cloud,
want to take the crypto part, Ethereum, Farcaster, whatever on that
Yeah,
side.
I assumed you were taking that since you already took it. So.
And yeah, for embedded, I don't have to think too much. So that is like, I can always help.
Yeah.
How do we connect to this Google module? It's on the cloud, but the rover doesn't have much power. So how does it work?
Grab a frame and submit it to the cloud via Wi-Fi. Is that it?
Well, and something has to take the response and translate that into movement commands. So where that lives is also a question.
Yeah.
But this can be done locally, right? It's not a very hard problem to send it to the cloud. No.
I think it just might be. I mean, it can be solved locally, but that does not mean it should be.
Yeah. But then the latency, it introduces some latency, right? If you want to control the motors, and then it's a little easier if it's done locally.
And in general, I think there's two considerations here. One is, as a general principle, how much no contact autonomy do we want? So in the case of like no connectivity, how capable do we want the rover to be? How much, or rather, how much degradation do we want to accept if without connectivity? And the other is, if you do want rover as the mission, Mars is 40 minutes latency. So if you're waiting 40 minutes to identify the charging pad, your battery will run out before you get to the charging pad, right? So there's some fairly tight constraints there.
We could also have some sort of mechanical.
I was going to say, certainly the GPU installation is going to arrive on Mars before we do.
Well, I wouldn't be sure of that, but definitely a mini Google Cloud, or maybe Amazon Cloud. Maybe we should be working on Amazon, not on Google, you know.
But in general, I think
probably
very high local capabilities. So like, just making this number up, something like 10% degradation if you're disconnected sounds nice. 90% degradation means you basically have like a dumb rock sitting somewhere. So I like the idea of like doing as much as you can, which means, okay, the question then is, what is the most powerful AI you can run on the most powerful computer we might use? So maybe ARPi 5 is the thing to calibrate against. What can you run on it?
So you can always have a PCI. So it has the PCI Express, and then you can have accelerators on top of it. So that is not an issue. And then if you want
sorry, go ahead.
And then we could also use OakD, so it has an internal AI accelerator, and then we just issue commands to that camera module. Or like if we want a GPU, then Jetsons are really good. They have low power. It's a little powerful than ARPi. It runs Ubuntu. And
I think power budget is an interesting question here, because if you're talking about charging specifically, you're already low on power. And then now you've got to do a very compute-intensive task to get more of it. Interesting.
Yeah, I remember looking up the Jetsons power demands. It draws quite heavy current. It's not a power cheap thing. Yeah.
Yeah, so it can be run on the dogs, the robot dogs you have. So they can run but like if you have Tumbler like robot, then we'll have to go maybe with ARPi.
So, but this is one thing where I would favor waiting, because I think next cycle hardware that's in the pipeline that I'm aware of, it's going to get like order of magnitude better price performance. So you'll be, and like performance per watt. I was looking at something very recently. But yeah, I think basically my conclusion from looking at this a few days ago is that the Jetson Nano is not worth targeting. It's like basically obsolete. We might as well wait for the next generation. So until then, we should look at what can be done natively, as well as like on other AI things. Like there's that STM something that I just posted.
STM32N6. It's a accelerator. STM32 ARM Cortex, and then they have the accelerator inside. But they are getting really beefier now, so it's going to run on 800 megahertz. I've never heard a microcontroller running more than like 400 megahertz. So they are going to run it on 800. It's like comparing small computers 20 years ago, that level of compute. And then Espressive has this ESP32 P5 or P6, something like P series. They are made for HMIs, but they are also on the same class as this STM32 new ones.
Okay, so I guess one interesting, so for my first session on like power, I'll plan on like leading a discussion on like just how to do power budgets. That thing you posted, Anuraj, from the course, I'll look at that spreadsheet and maybe we can do a session learning to think about this.
We should try to build some sort of Excel that if we input some sort of power budget, and then it will suggest a list of components which can be used within that power budget. Something like that we should build, and then people can just select, okay, this is the power, this is the size of the robot we want, and then they select. It will suggest you the power components according to the size and power of that robot. So if somebody wants to build a robo dog, so basically they will have a power budget for that robo dog, and then basically the other components would be suggested according to that.
So this is actually, if you think about it for a minute, this is equivalent to the knapsack problem, which is NP complete.
What is that?
Knapsack problem is you have a certain volume where you have to maximize the weight of items you carry in it, but each of the items also has a volume that takes up space in the backpack. So it's like a classic packing problem. Yeah. This is NP complete. And just looking at this first sight, it does seem like this is probably going to be equivalent to a knapsack problem. But yeah, I think you should be able to like make up a good heuristic spreadsheet that does like approximation. Yeah. So I'll finish going through that course and report back on what I learned and set up a couple of exercises. This part of the project interests me. I also bought, this was 6-7 months back, I bought the solar charging kit from Adafruit, and the Galaxy also has a power or solar power thing. Did you put that on, Red, the solar power thing?
It's on, but that's the one part I haven't done anything with yet.
Okay. So
yeah, I'm meeting a solar energy researcher next week. He's like, nice. Let's see what he shows me. So the university has some solar research, and they are there is also a solar farm nearby. There is no sun here in Oulu, but there is research.
I was gonna say the only person that should have some sun is Mayor. He should be our solar researcher.
Today and yesterday were completely cloudy.
Oh.
Well, completely cloudy. We still had some sunshine.
Yeah. Okay, so for the power management thing, the obvious first step is to learn to think about power budgets and how to like do the rough calculations. What's the obvious next step for image processing? Is it evaluating cloud versus onboard or options or something like that?
Kind of an R&D project of like, hey, run with VOD and pick a task.
Yeah, like let's take a simplest thing we need for the robo, and then we try different platforms, right?
I guess what would be the, like, does this not work without image processing?
So, I mean, anything you can find a different solution, like the charging positioning one, simpler way to do it would be to use like, all the simpler robots that use the light sensor and like a track type arrangement. You could do a little track, and at the end of the track, you place the charging station. You could do this with a simple photosensitive diode, right? But this is not general or interesting. I think having a camera-based fiduciary or fiducial solution seems like a good capability to have in general.
Yeah, but you don't need something so complicated. Just have a little blinking light and a light sensor that detects only the blinking light and, aims itself towards the blinking light.
Yeah, I mean, there's several such simple solutions. But the question is, do we want 100 simple solutions for 100 simple tactical problems? Or like Yasha said, use a camera for everything seems like actually a smart strategy to me, if you can, because then it's everything to AI.
The point is that if you're running out of battery, it's a life-threatening situation for the robot. So yeah, for life-threatening situation, maybe you want to have its own mechanism. And what I'm saying is this mechanism that I'm describing is very low power. Okay, using a camera to analyze an image or even capture the image and transmit it That takes power. But what I described was a blinking light. That could be a electrical circuit.
Yeah.
It doesn't even need.
Fair enough. Yeah. So I'll put that in my list of things to investigate. But okay,
But
yeah.
I still think that the last mile, or let's call it the last 5 inches, should be mechanical. In other words, when you get close to the charging pad, wait a minute. When you get close to the charging pad, there should be some sort of mechanical guide that guides you.
Yeah. Car washes have things like that, right? Like
exactly,
funnels you near the track, and then it catches at some point.
Right.
So yeah, you can do things like that. So okay, that's an interesting problem to think about. So I will think about it and come up with some proposals for us to discuss.
It should be 3D printable.
Yeah.
What isn't?
I mean, some things can be very simple. Like it could be as simple as a little piece of aluminum rod and then an equivalent slot on the robot, so that when it comes in, it just aligns on the track. So there's like very simple mechanical solutions for things like this that they use in like assembly line manufacturing. So the problem is not coming up with like options. The problem is coming up with, I think, interesting and simple ones that don't overcomplicate the overall design. Because the one thing that I think AI and cameras make interesting is, instead of having like 500 little spot solutions to 500 little problems like this, you can have like a few general mechanisms that each solve like 100 problems, right? So that's kind of what I'm thinking.
Yeah, well, you do realize that you have 100 different software solutions.
Yeah.
Okay, so you have the same complexity. It's just hidden inside.
The difference is you can do over-the-air update and like improve the software from a remote distance, but it's hard to like go physically change the robot. So as much functionality as you can move from hardware to software, you get some added complexity, but you do get the optionality of remote over-the-air updates, right? Like Tesla uses this strategy a lot. Like during the hurricane, they suddenly changed on, like they turned on the high mileage capacity of the battery. So the way they do it is the same battery pack, I believe, is in like different models of cars, but the more expensive versions like unlock more range or something like that. And during the hurricane, they soft unlocked it so that everybody would temporarily have more range. Yeah, I think this is what happened. I may be misremembering this.
I hadn't heard that.
Yeah, they can do things like this, but point is, yeah, it gives you optionality to do it in software.
It reminds me of I recall a computer manufacturer for servers would do that, where they all the dies have the same number of cores on them, but you pay extra to get them unlocked.
That is standard.
But Intel does this, right? Well, on the wafers, when
I guess they probably all do this to some extent.
Yeah,
And maybe there's like a quality thing, like you only have to have some of the cores have to pass QA.
So there's two levels here. One is actually a yield management problem. So if you have a number of dies, then 2 of them are flawed. You sell it as a 2-core instead of a 4-core. But there's also what you're talking about, which is there are no actual defects or faults. They literally just fuse out the parts if they don't want you to have like the more expensive capability.
But you could also pay to have it unlocked, like later.
I
think Compaq would do that back in the day. Yeah.
At the chip level, I believe they do fuse out the things.
Yeah, maybe it wasn't at the chip level. It could have been at like the.
Yeah, but
what do they call those things?
No reason it can't be reversible. Yeah. Oh, this brings up like another whole area of like crypto economics. Pay to unlock capabilities in the rover.
You mean beyond the ability to move?
Do you want to use the assistance of the AI to dock the rover to recharge, or are you going to do it yourself?
I don't know. I have to think about the problem, and I'll come back with maybe we should all do this for whatever problem we each choose to work on. come back with a proposal that's very low tech, one that's like maximally software and high tech and AI. So two proposals, and then we can have a good discussion about the comps.
Well, it brings back the statement. I have a friend who learned robotics, and his professor said that if when you have a problem, your solution is a robot, you're a bad engineer. So I'm asking, if when you have a problem, your solution is AI, does that make you a bad engineer?
I think increasingly it makes you real lazy.
Absolutely.
I mean, you're wrong, though.
I think your friend is wrong. Yeah. It's not fun. I mean, robots are fun. You don't always solve problems in the most efficient way. You sometimes solve them in the most, generally
Fun way.
an interesting way, right? I know Yasha, for example, likes to rant about humanoid robots. I think humanoid robots are very interesting. Yes, they may be if you're trying to replace like a kitchen blender with a humanoid robot holding like a spatula and stirring a pot, yes, it's a stupid solution compared to the blender for that specific problem, but it still like opens up like a very interesting design space because that robot can now basically use any passive element in the kitchen, right?
Yeah, if you have a humanoid robot, using it as a blender also is a good idea.
The real question is, can the humanoid robot stub its toe on the blender when it's left on the floor?
Does the humanoid robot blend? What was that YouTube channel? Will it blend?
Will it blend? Yeah.
It doesn't, yeah.
Oh, so, all right. Yeah, you were looking at the straw man list I made up of like functional areas that need coverage, right? Okay. I think we've covered maybe 1 out of 4 of these things, or at least experimented with it.
So could you dig in a little bit to what's the PCB needs that we're thinking here? What's next?
I was thinking of designing like a 3.3 volt a PCB for the tumbler based on the Freno, because I think all of us have the Freno kit, and then try to run that. That's the next step. I've not started it yet. So probably that, and then the first iteration is working well. I'll try to put it on a RPi hat format. So there is a template cutout you get of the RPi form factor, hat form factor, and then you just have to place your own components, and then it has the 40-pin RPi connector. So we could then just use the same board and then connect RPi when we are ready. So that's the plan right now.
RPi is a 5 volt part, right? Though.
No.
No, it's not.
Well, the SoC might be running on even lower 1.8 or something, but
the RPi board itself, the SBC, is it 5 volt?
I think the pins are 3.3.
Oh, they are? I didn't know that.
Yeah.
Okay. Huh.
I'm just guessing, but yeah, if I'm like just recalling correctly, then it's 3.3. The USBs are 5, but I think it has a PMIC chip on it, and that circulates both 3.3 and 5 volts on the board, and the pins are on 3.3.
You say PMI? Oh, power management IC.
Yeah, power management IC.
Yeah, the even on the Freno, like the power management chip on there will accept pretty wide range of voltage.
Mm.
The power,
but yeah, the
logic
LDOs,
level is wrong.
Actually, can we discuss this 3.3 versus 5 more generally? Like the ESP is 3.3, but is that like a general industry trend? Why is everything moving to 3.3, or like what's the whole logic?
So you save power, right?
Is that the only reason?
Well, yeah. So basically, initially TTL was just 5 volts, and then when 3.3 CMOS came out, so everybody started moving to lower voltages. But these days, you can also run many of these microcontrollers at 1.8, because like if you have like battery power stuff, the lower voltage you use, less power you use.
Okay, and what is the state of the transition? Like, are most components now available in 3.3 variants, or is there?
Yeah, most of them. Yes, and these days you also have this PMIC chips that take 1 voltage and supply 5 volt and 3.3 volt at the same time,
Okay,
and then you can circulate that on your board.
okay,
I think it's just generally the sensors that we get in like Arduino kits all still live in this ecosystem of the Atmel, whatever that chipset is for Arduinos, run at 5 volts, but like nothing else does.
Oh, okay. So
it seems like anything in like the ARM world or the ESP32 world, all that stuff's 3.
okay.
And it's only the older Arduino stuff is.
So we should imagine a universe that's 3.3 digital electronics and maybe 6 or 12 volts for any motor type parts, right? That's basically it.
I think that's right. And also, I don't know if you guys remember the PCB I designed incorrectly because I did not have, because I'm using the chips I was using for the motor controllers are actually 5 volt motor controllers, and it didn't even occur to me that I was wiring these up to a 3.3, the ESP32, and it still works reasonably. Like, I'm not saying it's 100% right, but like it doesn't not work. Like it's completely functional, which is kind of interesting.
The ESPs are, I think, 5 volt tolerant, but I think it's because that Arduino board itself causes problems with 5 volts. That
Arduino
well,
in this situation, it's just the logic level coming out of the like to signal the chip to like turn on different directions. Instead of pulling it high to 5, it's only pulling it high to 3.3.
Yeah,
and that's good enough.
So there is a voltage called VI edge. So V input high. So it's generally around 3 or 3.3 something. So if it goes above that for 5 volt range, then it will clock in as high.
Yeah.
So right now you're using the ESP Arduino Nano thing in your breakout type board, but you want to redesign around the what is it? The
FreeNode.
FreeNode. Okay.
Yeah, the FreeNode kit, because it has 2 USB ports, and then one is the USB on the go, and then one can be used for programming. So then we can connect.
Camera, right?
Sorry.
It also has a camera, if I remember correct.
Yes.
Okay, the same one I bought it. I couldn't get it to work. Okay.
Yeah, so we had the discussion about the pin budget, but let's try to get out one iteration first. Then we can check how to handle the camera part.
Okay. And your intent is still to basically reproduce the LEGO board at 3.3, like it's
yes. Yeah.
And what else is on the board? Like, what are we talking about that we're preserving here?
So there is accelerometer on board already. Then there is ultrasonic sensor. And then I had added the temperature and humidity sensor. We could add the GPS. And what else?
Are those
the encoders,
I2C devices, or are these
yeah, so the temperature humidity sensor, I think, is the ultrasonic, and the accelerometer are all I2C.
Yeah.
And then the GPS is UART.
Okay.
And the encoders are directly you have to connect it to the pins. So encoders, we could then have the tumbler as a self-balancing robot if the encoders start working.
And even if you don't use self-balancing, it's generally useful to have the encoder to like track turns and distance and things like that.
Yeah, so that way it would be useful. Maybe we might even not need that camera-based positioning to know. We kind of have odometry.
No, in my experience, these things are too accurate, and errors will accumulate enough over like even fairly small distances that your positioning accuracy will go to hell, basically. If you rely on encoders over like more than 10 inches or something, it'll drift a lot. Yeah, this is basically the dead reckoning versus like external reference reckoning problem. And yeah, unless you have like a very accurate gyroscope or something, which wonder if the onboard gyroscope plus the encoders together will have enough accuracy. But okay, that's another thing to think about later. What else on this list is worth talking about? Like the reason I made this list is I was thinking if we can like actually define this project well enough and like mark this list as we have somebody who knows this stuff, this is open for somebody to come and take. This makes it easy to write a newsletter or solicitation saying, hey, if you want to like play with this functional piece, join our team.
So the web programming stuff, web app, that I don't know if somebody of us is comfortable. For me, it's like energy draining stuff.
Is that like when we're talking about web programming? Are we talking about like the Farcaster?
Not Farcaster specifically. Yeah, that is one part of it. But yeah, it would be nice to have like somebody who takes care of, because for me it takes a lot of time and searching, and then well, it's not like embedded for me.
So you're doing PCB and then the Ethereum Farcaster piece, and then somebody you would like to plug in and do the web programming piece of it.
Yeah.
Okay. Can we talk about the VPN stuff as well? Is that problem already solved and it was just a small glitch at DevCon, or is there like more work to be done building a robust networking?
Yeah. Well, like we could play with it, but I'm not a networking expert, so I don't know.
What are you two thinking of like picking as your areas, Mayor and Rhett? What appeals to you? Doesn't have to be on this list. This is just a straw man.
Yeah, I'm trying to figure out what pieces are, I mean, I guess difficult to express. I want it to be like applicable to more than just the Tumblr specific project. Like happy to fit into the overall ecosystem, but like, well, maybe I want this rover over here to be able to plug into it. What does that mean? So kind of an interoperability layer.
Yeah. We should definitely at least plan for those two rovers, Tumblr and the Galaxy, since we have two of each at least.
Yeah.
But it would be nice to have like a more general interoperability sort of model where somebody comes up with a nice new rover tomorrow, we can just say, all right, follow this recipe cookbook and it fits.
Yeah. I think the image processing and AI stuff, like I've got that OakD, never quite went down far enough into any of the projects besides just pulling images and video off of it. So I'm certainly very interested in pushing specifically the OakD. Other non-local AI stuff, I've certainly done pieces of, and it's still kind of cool, but probably doing OakD is probably an interesting experiment, an R&D direction.
I don't know yet. I'm trying to figure out how much time I have. I don't want to take a task and not do it.
I mean, we should try and think of this as not as much as possible. We should not do any necessary things. We should use the basic, but you know what I mean, right? Because that allows decoupling of individual tracks. If we rely on the default out of the box functionality of the Tumblr or whatever off the shelf rover we use, and it already solves a problem well enough and everybody hates solving that particular problem, we just stick with the off the shelf solution and only focus on like building the parts we want to. Like if we build more momentum, then we can do things like, here are the 10 essential things for the architecture to work, and we really must have this piece covered, right? Like ROS, for example, if nobody likes ROS, nobody wants to work on RTOS stuff, we can kind of just go with whatever scheme the Tumblr has for running the software. What does it use? I don't know.
If you're using, so RTOS I can handle. RTOS and that embedded thing, like that we have solved. Don't worry about it. If somebody has problem, I can solve it.
But ROS is one abstraction layer above, right? So we've talked about it a bunch of times, and I think Victor tried to play with it once, but I don't think we've ever actually done anything with ROS.
Well, I use it at work, so
okay.
And it So it will be there for a long time, and somebody has to do it. And
Does somebody have to do it? I mean, is it an essential?
Or just no.
well, if there is some so RTOS basically it's like a different stuff than ROS, but ROS will be there in the industry because of the legacy reasons. It will be there.
Yeah, but
People
for the rover project, if we don't like it, can you build?
then we don't have to use it. No,
Okay, yeah, that's
but
what.
at least RTOS will have to use.
Okay,
And
so
RTOS is basically I would put it in the first point instead of 9.
Yeah.
okay. So this is just me not knowing where to
Yeah.
put stuff.
Yeah.
So I think one interesting meeting to have would be put this in a spreadsheet and like classify them as like must have, nice to have, which I started doing here, but it's like half-assed. And
Yeah.
Can we use the off-the-shelf, or do we really need some custom development? Like it, for example, the ESP32 shift and designing a PCB for that. It sounds like it's a must-have because that's the only way we can get Wi-Fi connectivity, right? Because on the 5-volt Arduino, there's only Bluetooth.
Yeah, so it uses a separate Bluetooth chip, but let's say so now Microchip and Silicon Labs both have come up with their own, and I think Infineon also has this own Wi-Fi chips. But I would say ESP has the most mature stack
Okay.
for Wi-Fi. They have been doing it for 10 years, and these players are. But yeah, doesn't matter because these are large companies. But I would stick with ESP right now.
Yeah, my point is that's not an item where we can simply say let's just use the default and not do it ourselves, because there is no default that actually does it, right? Like the Galaxy uses some the ESP CAM chip to do it in a weird pass-through way. The Tumbler doesn't do it at all. I don't know if you've looked at other hobby robots. I'm sure some of them use Wi-Fi, but it's not clear that there's any rover with out-of-the-box good Wi-Fi. Same thing with like cell modem type thing. So far, I don't think I've seen any cheap kit that connects to cell.
On the existing Tumbler, is there a possibility of doing a similar architecture to the Galaxy where the brain that exists today stays and you just communicate it with it over UART?
It's possible, because only the difference would be instead of the Arduino, we would be running that part of the motor control part on an ESP32, because we have two ESP32s on the Tumbler, and there are two microcontroller on the Galaxy. So it's kind of similar architecture. All the software running is different.
No, I think Rod is asking something different. It's not your modified version, but the out-of-the-box Tumbler. Is that what you were asking?
No.
Yeah, I'm saying like, why not? Like, can you just do the out-of-the-box one and then communicate with it, like we use the Galaxy out-of-the-box and communicate with it?
It should be possible to port the Galaxy software to my modified Tumbler.
But the original out-of-the-box Tumbler cannot handle the Galaxy architecture, is your opinion? Okay.
Yeah, but there is no the microcontroller doesn't work, right? It doesn't have Wi-Fi.
No. But I'm saying.
Okay.
So the way that the Galaxy, it also doesn't have Wi-Fi. The controller that you connect to the Arduino has Wi-Fi. So it's kind of like, it's a strange architecture, but I think we could do the same thing. So instead of like replacing the microcontroller on the Tumbler, just communicate with it.
Yes.
Yeah, I think it's possible, but still there are no pins coming out. I think you might have to still do some modifications.
Wait, I thought there is like 2 rows of pins in the original board.
But all of them are used for so they are for probing, something like if you want to probe those pins. Because all of them are used on the.
Okay.
There might be, but it's connected to, I think, the Bluetooth.
The way the Galaxy solves this is that it has a switch on it that you can switch between programming mode and, I guess, run mode. So it's using the same connection that you would like if you plug your laptop into it with a USB.
Okay.
It switches between the USB connection and the UART connection to the ESP cam.
I have
Is
to
that
check
correct?
the board. But the last time I checked the tumbler board, all of its pins were used for something on the PCB itself.
But does it have a? But you can plug in USB
Yeah, you can
and get
plug
a
in
and get
USB.
a
Yes,
serial. Yeah.
yes, yes.
Oh, okay.
But
So then you could just plug the ESP cam into the USB and use the ESP cam as the Wi-Fi point.
no, because the Arduino doesn't have a native USB, right? Or
Yeah, this is, I think, worth
yeah,
at least
yeah.
I mean,
a bit of
this is
info.
a crazy architecture, and I would never have thought about it if it weren't for the Galaxy. And I was like, really? What are you doing? Oh, the ESP32 just rides on top of the Arduino and drives it around.
Like
Wow.
if you put enough effort to it, then yeah, we can run the same thing.
Well, I'm actually wondering if it's easier. That's
Yeah.
not.
If it is too janky, we shouldn't do it. But if it actually looks like an elegant pattern, we should consider it. Does it feel like it's a good general pattern that's worth
It
doubling
doesn't
down on?
feel, to me, it doesn't feel less janky than like building a PCB to like hijack the brain. I mean, I don't hate either one of those. I think they're kind of cool, but
Just one question to calibrate me. We're talking about using frames v.2, which allow a much better, faster control and feedback, right?
Yeah, you can think of it as a small browser-based web app that runs inside the Farcaster a Webcast app.
Which runs on a frame server, which will be an RPi in our case, right?
One architecture is that, or like you could have just a like current system we have that only the affordances are exposed via the ESP32, and then there is a separate frame server running somewhere, either on the RPi locally or on the cloud.
So I think the version of this, your roadmap that I like is if you build your ESP32 board in the form of an RPi hat, and we can actually get to the big computer, little computer architecture, then this is like, it's worth designing a full PCB. So, but if it's not in the form of an RPi hat and it does not open up the RPi roadmap.
Yeah, so that was my plan. So I'll prefer that, because then we can, when we have the RPi, we can just plug it in.
Yeah, if that's what we're planning, I would definitely go for that. The Galaxy one, I think fundamentally it doesn't have headroom to grow, right? Like how would we attach an RPi to the Galaxy in its current form?
You would replace the ESP cam with an RPi.
Huh, okay. That's another way to go. So the RPi.
And I already have that protocol reversed. I have code to like write that protocol.
Okay, so then Anuraj, my question to you is, if you're making it in the form of an RPi hat, the RPi already has Wi-Fi. That makes it a little bit of a moot point. Why are we creating an ESP32 based hat if the motivation for ESP32 is Wi-Fi? If the RPi does Wi-Fi, then like a much simpler.
Then you have to depend on the higher power computer for Wi-Fi.
Okay, that's a good reason. This way you can turn off the RPi when power is low and just work with the. You'd have to independently power the hat, but yeah, it could work in low power mode and still have connectivity. So low power.
The RPi is going to pull a lot more power than that.
Okay. So
even with Wi-Fi, I guess. Yeah.
All right. I'm just trying to get the logic straight. So the motivating reason for RPi plus ESP32 hat is low power Wi-Fi connectivity. Is this a good reason? Okay. And the ESP32 is also generally doing all the low-level functions, including motor control, basic navigation, but maybe not camera. If we have an RPi running, then maybe camera is an RPi function and ESP32 does not do camera. Because camera is fairly expensive, right, power-wise?
I have to check, but it might be low power if we run it on the ESP32.
So again, camera is one of those very general open-ended things. We can have like a better high-resolution camera running on the RPi and then a very quick and dirty camera running on the ESP.
ChatGPT estimates that the Wi-Fi on the ESP32 is going to be running at like 200 and 250 milliamps, and Raspberry Pi 02 is going to be like 1.2 watts.
Yeah, I did do this comparison a while back. Yeah, ARPA is fairly thirsty. If you look at the power brick that comes with an ARPA, it's like as big as a laptop power brick. It's
well, this would be like if we were to use the ARPA 02 is like pretty tiny compared to like the full one, and the power usage is way less.
Okay.
But like an ARPA 5 is like would be huge for the demands.
So I should probably start making a list of action items or discussion items. So sounds like one of the discussions we should have is pick the ARPA big brain form factor is somewhere between ARPA 0 to ARPA 5.
Yeah. But, saying, also it's not really fair to say like, well, the ARPA is 5x more energy, has 5x more demand for energy. Therefore, we shouldn't do it. Like, we don't know what our budget is.
Yeah, so there's like a bunch of interrelated questions here. What's the overall power budget? And there's no reason we can't have two architectures, like a high power architecture for a slightly larger rover, and then like a mini rover architecture that can, so we can give people like a $500 option and a $200 option, right?
Yeah, so like that's what I was saying. So kind of some sort of Excel where people have like a budget and power, and then we have the components listed for that budget and power.
Yeah. So we should have that kind of model available. But I think in the short term, really what's going to happen is we're going to recommend a couple of off-the-shelf rovers, probably going to be Tumbler and Galaxy and maybe one more that fit whatever like first pass interoperability standard we're looking at. And then we'll have maybe two modified architectures. So the modified Galaxy architecture and the modified Tumbler architecture, and hopefully they will converge, right? And the convergence point should maybe be the ARPA. Like, can we get the Galaxy and Tumbler to converge on an ARPA big brain? Yeah.
Okay. Yeah, just 2 minutes left. I think it was a good discussion today.
Yeah. I will be missing next week. I'm traveling for work, but I will start thinking about power piece for myself.
Okay.
All right. See you guys.
Okay. Bye.